Hello, everyone. I received a question about problem number 10 from the Module 2 homework, and so I'm going to try to answer it here with a short video. So first of all, I want to give a quick review of what all of this terminology and these different symbols mean. So for one thing, I'll point out that here on a graph, any point on a graph, so any point in this coordinate system has an input and an output. So for this point right here, and let's see if I can do this. Sorry about that. Here we go. For this point right here, let me change the color to red so we can see it better. That point on the graph has an input of 0 and an output of 4. The horizontal axis tells you your inputs, the vertical axis tells you your outputs. So that point right there is the point 0, 4. So if we come over here and we look at this first question, part 1 here, says evaluate g at 0. In other words, it's saying for this function g, this function right here is labeled g, when the input is 0, what's the output? And we see here that the output is 4 when the input is 0. So therefore, that must be that this question over here is saying to take the function g and evaluate it at -1, g at -1. And it's saying g at -1 results in some output. So g at -1, well, first I have to find -1 on my horizontal axis. That's right here, -1. And I want to evaluate the function g at -1. And g at -1, if I come up here, right at this point here, g at -1 falls on the graph at -1, 3. And so therefore my output is 3 when my input is -1. So remember from our function notation, we said y is a function of x, y is my output, which means also that f of x is my output because they're equal to each other. They're both representing output. So g at 0 is actually representing the output when. The output when the input is 0, specifically in that case. G at -1, that's also representing an output when the input is -1. So when the input is -1, the output is 3. When we get down here and look at this question, now there's asking us find A when G of A is -2. So when the output is -2, when does that occur? What input causes the output to be -2? So now I need to look at my vertical axis, find -2, that's here. When is my output equal to -2? That's right here. Well, what input caused that? The input that caused that would be, so we're looking for this input here. At what input will the output be -2? So I come up here to my horizontal axis and I see, oh, that's -3 here. So this must be halfway between -3 and -2 is -2.5. So when when my input is equal to -2.5, my output is equal to -2. So one more here. This is saying solve. Solve means, remember from the PowerPoint, solve means to find the input when we know the output. So here I know the output is 0. Let me erase a few things on the graph here so that I have a little more room to work. Okay, so the question is for this function g, lost my pencil. For this function g, when is the output 0? Well, the output is 0 whenever the function crosses this horizontal line. And that happens right here. And it kind of looks like it happens here, but it really doesn't, because that's an open circle, which means that the graph isn't actually touching there. That's a hole. It's not actually touching. So it's really only in one place, and that is when a equals -2. So when a equals -2, G at a, or my output, is equal to 0. All right, now let's talk about domain and range. So if you remember from the PowerPoint slides, domain is the set of all the possible inputs, and the range is the set of all the possible outputs. So when I look at this graph that's shown here, this graph is only defined for the values that are actually shown in the image. So this graph doesn't go beyond in either direction. There's no arrows on it, so it doesn't continue forever and ever. It just stops. And so I need to ask myself for the domain, what's the smallest possible input value? And what's the largest possible input value? So here I see that over here, at a equal -3, that's the farthest to the left that I see any points on my graph. And over here at a equal 2, that's the farthest to the right that I see any points on my graph. So I can say that a must be between -3, and it could actually equal -3 and 2, but it can't actually equal 2, because remember, that's a hole there. And I can write it using that type of notation, or I can use the interval notation, -3, 2, where the open, this rounded bracket implies that I'm not actually including that. I'm just getting close to it, but not including it. The square bracket says, yes, I am including that point. It's like the less than or equal to sign. And then for range, we have to ask the same question. How high does my graph go? And how low does my graph go? So I can see the maximum value that my graph ever gets is up here at 4. So I know that B is going to be less than or equal to 4. What's the smallest that my graph ever gets, or the lowest? Looks like down here at -5. So I know that B cannot be lower than, and all of a sudden my pencil's not working again, cannot be lower than -5. It could equal -5, but it can't go lower than -5. That's that point there. So again, using interval notation from -5 to 4, that's telling me that I can't go lower than -5, I can't go higher than 4. Be careful, interval notation is not the same thing as a point. A point up here, remember, has an input and an output. Interval notation tells me the beginning of my interval and the end of my interval, including everything in the middle. So then finally, is this inverse the inverse a function? So if I were to change this, instead of looking at my horizontal axis as my input and my vertical axis as my output, what if I changed it so that my vertical axis was now my input and my horizontal axis was now my output? In other words, what if I changed it so that these B values were my inputs and these A values were my outputs? Well, I can see already that I'm going to have a problem, because if my input was 2 right here, I don't know why sometimes my pencil just stopped working. But if my input was 2, I would have 2 possible outputs. I would say, oh, for an input of 2, remember now, if B were my inputs, then my output would either be -1.5 or +1.5. And that can't be the case. Functions can't have two possibilities for an output. If you know what the input is, there can only be one output that matches with that input. I can't say, oh, when I put in a 2, let's see, maybe I'll get out a -1.5. Maybe I'll get out a +1.5. No, we have to know for sure what we're going to get out. We can't have options. So is the inverse a function? No. That would give us one input with multiple outputs, and that can't be the case for a function. Okay, well, I hope this was useful, and if you have more questions, please let me know.